It's about to start. We'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound check, camera check, lights check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause this stream is about to start. Get ready wherever you are, 'cause this stream is about to start. Hi, I'm Leandro Facchinetti, and let's write some code together, shall we? What we have on the menu today is to continue exploring, or as we are about to see, stop exploring JSJSFX, which is this approach that I am coming up with to develop real-time audio effects for REAPER. And JSFX is the language in which you write audio effects for REAPER. And JSJSFX is this approach that I'm coming up with, that is to write a JavaScript program that generates JS effects. And that is to work around some limitations of the JSFX language. We have explored how to write JS effects in the traditional way, using the features for pseudo objects. Then we explored the concept of using real objects. What I'm calling real objects is just this idea of using memory to store the parts of the objects. And when I say things like objects, I mean if you have like a filter, a low-pass filter, for instance, you need to keep around some private information to that filter, like the previous samples that came in and that sort of thing that is necessary to compute the filter. And real objects is using the memory feature in JSFX to work. Pseudo objects in JSFX is a feature that comes with JSFX, and it is something that it is called a pseudo object, so you can imagine that it has some limitations. And I guess the major limitation is that pseudo objects are not values. You cannot put pseudo objects in an array, for instance. And then I came up with the JSJSFX approach to overcome this. So instead of using pseudo objects, I would just copy and paste essentially a lot of code. This JavaScript program is something that spits out a lot of some big files. And then I don't need to put things in an array because I know what the size of the array is going to be. I just define that many variables. And so we explored all these approaches in the stream recently, in the past few weeks. And I had some time to think about it, and I think I reached a conclusion of things that are working, things that are not working, and today is, I guess, the day where we are going to clean everything up. So let's go over what we have here, which is a lot of junk, and clean things up. So to begin with, we have this test file. I think that one is going to be easy to clean up. Then let's go to the meat of the thing, the JavaScript part of the thing. Well, it doesn't look all that nice. The code that you end up writing is kind of complicated. I still think there is value to doing this here and there, depending on what you're doing. Like, for instance, in REAQ, we talked to Justin here on this channel a couple weeks ago. Justin, who created REAQ, has a filter that instead of using a window of samples stored in memory, it just has, because the filter kernel is so small, you only have to store 64 samples. What Justin does is he has variables for the 64 samples. But that approach only works if your filter kernel is somewhat small, like 64 samples. If, like, we wrote a little JSJSFX program that generated a window of 10,000 items, and unsurprisingly, it was bad. It was super slow, and it took a lot of time even to load because it had to compile, right? So big programs take longer to compile. So I think there is value in writing JavaScript programs that generate JS effects. In fact, it's sort of an approach that we used already when we were defining the colors. Here is a little JavaScript program that generated this chunk of JS effects. And I think there is value in writing this from time to time, depending on what you're doing, like if you're doing the filter kernel thing that I just mentioned, or if you're doing this. But as an approach for everyday programming in JSJSFX, or for everyday programming in JSFX, I don't think I like it. It gets too complicated, and it is true that using JavaScript, we can create abstractions like this that are easier to read in the sense that everything is more explicit. So if you want to define a slider in JSFX, it looks like this. And if you don't know what the positions are, it can be kind of hard to understand. What is this 0? What is minus 100 and 100? While in the JSJSFX version, I created abstractions for that. So minimum and maximum, that is pretty clear in the step of that slider. So all of this makes a lot more sense. So maybe if I was designing a language for other people to use, maybe if it was 2005 and I was developing JSFX, I think it could make sense to go with something more explicit. But if I go with this approach, I am pretty sure I'm painting myself in the corner. No one else is going to want to learn another language on top of JSFX for many reasons. I guess the reason that stands out is that people already know JSFX to some extent. It's a small community, but it exists. Also, it's not so bad. Once you learn it, it's not a terribly designed language. I think, personally, I would prefer something more descriptive, but it's not too bad. And then I would be asking people who want to use my tools to learn JSFX, though there is no way around that. You need to know the language that you're going to compile into. There's no way for me to abstract that too much. At least you need to know the sorts of limitations that go into JSFX and that go into real-time audio programming in general. So the person would have to learn JSFX and then learn my abstractions on top. I don't think it's worth it. So JSJSFX is dying today. That's the truth of the matter. And the approach that we are going to go with is not exactly JSJSFX, though it may occur here and there. It's going to live forever in our hearts. It's also not quite what we have been doing with real objects, but it's also not quite what people do with pseudo objects either. So pseudo objects have some limitations that I don't really like, because you cannot use pseudo objects in data structures. You cannot return a pseudo object from a function and that sort of thing. You cannot pass a pseudo object as an argument to a function. All those sorts of limitations. Depending on the plugin that you are doing, it doesn't really matter all that much. It boils down to you having to copy and paste some code for the left and right channels or something like that. But as your code kind of grows, or your effect is doing anything besides just the trivial stuff, having that sort of ability kind of comes in handy. For instance, in REQ, Justin has a series of filters. So if you want to do a low-pass filter with a steep curve, then, like, for instance, a 48 dB per octave kind of slope, then you need to cascade several filters in a row. And the way that he does that is by copying and pasting the code, which is fine. And he's using pseudo objects for that, and that's okay. But we measure the performance, and I guess one of the main reasons to do it that way is that it's going to give you better performance. But we wrote some stress tests, and we determined that the performance gain was not amazing, not at least for the exact thing that I'm mentioning, a cascade of filters. I had 100 filters, or maybe 1,000 filters, I forget. I had a bunch of filters. 1,000 filters. So I had 1,000 filters, and the difference was, while I was streaming and everything, so it was kind of a good stress test. The performance with real objects was like taking 25% of my CPU. With pseudo objects, using the JSJSFX approach, we wrote a filter just like this. And using the pseudo objects, it went down to 20%. So that's a 5% CPU difference. And it's not trivial. It's not something that I would throw out. But it's also not something that like stands out as, oh my God, all plugins need to use pseudo objects all the time. So we are going to go with an approach that is similar to the real objects, but not quite what we have been doing. There are some things that, well, I think that it's good that we went overboard with all the different approaches. We went overboard with the JSJSFX approach. We wrote a plugin that had 100,000 variables. Oh, Fotis and stuff is here. Hey, Fotis. Great to have you here. I think you are going to enjoy this whole discussion that I'm having today. It is about the approach that I want to use moving forward with the library. So one thing that I did is I went overboard with the JSJSFX approach. I wrote a plugin with hundreds of thousands of variables. Okay, I went overboard with the objects approach, the real objects approach. And in the real objects approach, I made everything an object. I think that there are some things that benefit from being objects. For instance, the filters that I just mentioned. Sometimes you want to cascade them, or you want to turn them on and off, or you want to automate them in wacky ways. So it's advantageous to have filters as real objects. But there are some other parts of the, I guess, data structures and infrastructure that don't really benefit all that much from being real objects. For instance, the structs. They are real objects. You could have an array of structs, and then you could have maybe something that is going to go over the array and instantiate all the different kinds of structs. But in reality, if you think about it, you should only be allocating structs in the init block when your plugin is starting. Maybe you would want to do that in the slider block, but you definitely don't want to do it all the time. So I guess in the init block, you could just copy and paste the code a little or write a little snippet of JavaScript. In any case, there are other ways of going around this without having to have structs as objects. And if you think about other programming languages, it kind of makes sense. The approach that, I guess, the original JSJSFX pseudo objects, the approach used by that is similar to the approach used in things like, I want to say C, but not even that, because in C we do have structs. So it's a very rudimentary abstraction. The thing that we built together with real objects, it's more like JavaScript or Ruby, languages in which everything is an object. You have control over everything. Even, for instance, in Ruby, even classes are objects. So you can have an array of classes, not an array of objects, but an array of classes, because classes are objects. And that kind of flexibility and metaprogramming is super useful in languages like Ruby and JavaScript, but not quite in what we are doing here. So I guess the approach that I want to take is the approach in which the structs will not be values. Objects will be full-blown values. So I guess it's the Java approach, because in Java, unless you're using some weird APIs that you should try to avoid, like the reflection API, in Java, a class is not an object. You cannot pass a class as an argument to a function. You can pass an object as an argument to a function, but you cannot pass a class. A class is not a first class value like that. And that's, I guess, a sweet spot for what we are doing. So in essence, we are developing real-time audio effects, all right, yeah, but we are also trying to find the best way to go about that. What works and what doesn't work in terms of abstractions, and there is always a cost, right? For every abstraction we introduce, there is the cost of understanding, maintaining, and even running it in case it takes more CPU cycles. So we have to ponder the pros and cons. And I think we're finding a sweet spot. So let's continue with this cleanup. Because we are getting rid of the JSJSFX approach, I can get rid of this and that, and also this. Good. Then, and all of this has been in my repository in the Git history, so it's not gone forever. If we want to refer back to those, we can. I just pushed, so now you all can see it as well on GitHub. Let's look at this file. I think that there isn't a single thing in this file that we want to preserve. And this is kind of cute. We could do some detection or some checks because we had those kinds of abstractions, but I'm getting rid of them. Yeah, there is nothing here that we need to preserve. Then there is this first exploration here that, again, I don't think there is anything useful in here. It's mostly just a big JSFX file. 10,000 times 64. So it's going to generate a big file. In fact, the big file that it's going to generate is on my machine, and I should get rid of that. I think it's going to be here. And let's see what we have. Oh, so look at that. That's one of those big files. Getting rid of that one. And that's another one, another big file. Getting rid of that. This is a stress test. And this is, I guess, the biggest file I produced. It's like hundreds of thousands of lines or even millions of lines. And this is the equivalent using objects. See, it really pays off if you need, for whatever reason, to have like many waveform drawings. Pays off to do code like this, especially for the user interface. I guess most of the conversation we have about performance and that kind of thing is for the processing of the audio, but for the graphical user interface, doesn't really matter if you access memory in a loop. It's going to be fast enough. So, all right, okay, that's a good one, but we already stress test the thing. And then here it's just a bunch of no-ops. I'm not really sure what we were going for here. Oh, yeah, we were working on the sliders, and we were working on this, which I called the runtime system, but essentially something we are getting rid of. And then there is the library itself, which I am not sure if I have the latest version over here, so I'm gonna rename this to that and then move it over there. And let's compare the two. So right click, select for compare, right click, compare with selected, and the files are the same. So we can say goodbye to that one. Then moving forward, this ball drop is not related to the JSJSFX approach. It's just something that Arya and I are developing together on our Monday streams from time to time. I'm gonna move this there. This is the library itself, so we are going to keep this and we are going to iterate on what is there. This is something that we also want to keep because it's going to be the first plugin that is actually going to use the library. This, I'm not really sure we need anymore. yeah, we did this one. We implemented waveforms with variables, and then the rest of this doesn't really matter all that much. Then this is a sketch. I guess I'm going to move this to the to-do folder as well. It's a sketch of a compressor that we developed together on the stream a while back. This is using the library, but it's an old version of the library, so this code doesn't even work. Then demonstration effect is something that we want to keep together because it goes along with this one. But I also had an idea for what the demonstration effect should be. Right now, it is just trying to exercise most parts of the library, but I think it makes more sense to actually use, for instance, we have in the library this implementation of something that limits the skew. I'm calling this smooth. Forget what I'm calling it. Follower, calling it the follower. So we have an implementation of this and it's used here. So I don't think it makes a lot of sense to have a standalone demonstration effect that is essentially just going to be copy and paste of this. So yes, I'm going to develop real effects that use the features, and I'm going to document in the library which effects you can use to see the thing in use. And Fati says, the fate of JSJSFX is a very dramatic title, like a fantasy movie where JSJSFX is a fallen angel. Yeah, it is dying, but it's going to live forever. Right, so the demonstration effect is going to be broken apart in multiple effects. I will have, for instance, one effect for generating noise, and I will have one effect that is a simple bunch of filters, that sort of thing. And not maybe some of them will not be super useful because they will be so bare bones. Like, I don't plan on implementing a lot of user interface for filters, but I think that we should have some effect that does filtering. Now, this memory visualizer is kind of a cool trick that I want to keep around because I want it to be part of the library. So everything that is in here makes sense. And then over there, we have cleaned things up. And then I guess I'm going to rename this folder. I'm going to call this JSFX library. I don't know. Something like that. And I'm going to rename this to Ode. Because we are going to more or less restart this from scratch, but using this different style that I'm mentioning, where structs are not objects because I think that they just add clutter to the code base. And there are some tricks that we can use to optimize some data structures. For instance, we have a data structure for arrays, and it looks like this. I think there is a better way to define this. The array data structure is just a chunk of memory, but it does remember its own size, which is crucial. So the way that this works right now is that we have sort of a data structure with two fields: size and data. And the positions of these fields in memory are 0 and 1. So if you have an array, so you did something like this, an array of 100 positions, you can go to the array and ask for the data. Now, what I don't like about this is that, first, it's kind of annoying to write, because then if you want to have position 2 or the third element in that array, you have to write something like this. Now, I don't like this for several reasons. The first is I don't like the way it reads, because you have to do this. Second, you are doing extra memory, one extra memory access here to get a hold of the data. And then you index into that. And third, we know that the data is going to live in this position. So it is kind of wasting memory as well, which is not a big deal. It's just one slot in memory, but still, it's wasting memory. So it's wasting resources and making our code harder to read. So here's a trick that I thought about using. But if we allocate the same amount of memory, but we index it like this, then to get the size, you still get to do something like this, right? It's a special field. But to get the data in the array, you can just go ahead and get it. This is going to save us some typing, it's going to save us some memory, and it's going to save us a memory access every time. So it's going to be faster and easier to read. It's a win-win situation. So because of these changes, and also some naming changes that are going to fall out of the notion of structs not being objects, all of this makes most of this code wrong. It's going to look different. The logic is going to be the same. So if you look at the implementation of the RBJ filters, all of this stands. The formulas are right, everything is okay, and we'll be able to copy and paste a lot. But the naming convention is going to change, and we will implement some of these clever little tricks to make things easier to read and slightly faster. So let's restart the library. Hooray, a new library. Where do we even start? I think I'm going to start with memory, because we have some algorithms like how to compute filters, we have RMS, we have SVF, we have the discrete Fourier transform, but it all boils down to data structures. So let's revisit data structures, or maybe even revisit some of these functions, because they may be a cheap way to start things. Right? All of these conversions and whatnot. Yeah. Let's have a low-hanging fruit first to have something on the page. Then we can go to data structures. Let's see what we want to change about this. Someone suggested that I used ms instead of milliseconds, because milliseconds is a long word and ms is the standard abbreviation, but I don't know. MS could also mean like mid-side, can mean many other things in the context of audio, so I think I'm gonna keep this long name. And I do like the underscores for the library functions, so that naming convention is gonna stand. Milliseconds to samples, all of this makes sense. I think I'm gonna change it around like this, because this number actually refers to the milliseconds, right? Converting milliseconds into seconds and then multiplying by the sample rate. And then samples 2 milliseconds. I guess, again, same story. Well, not quite. In this case, I think it may make more sense to have this 1000 here. Yeah. Okay, I take it back. This is like converting the sample rate, which is expressed in seconds, into something expressed in milliseconds. Fair enough. It's just the order of arguments. It doesn't really matter. One thing that we could do is to make this faster. We could have a variable that is 1 over sample rate and then we could multiply. And that's faster because multiplication is always faster than division, but do I want to do that? No, I do not. Makes the code harder to read, and unless we find at some point that this is a bottleneck, And then we could just go ahead and do this, right? It's not going to change the interface or anything. No one's going to be unhappy. Nothing's going to break. So I'm going to leave that just like that. I guess I could even store this, because this is a constant. Oh, and Bo is here. Hello, Bo. Great to have you here. Loved your song, by the way. Yeah. Okay. Let's do that. Oh, you know what is cute about this is that we could store this constant, and then the way you convert between milliseconds to samples is just by multiplying. If you have like 100 milliseconds times that, and you got yourself samples. You don't need to call a function. That is kind of cute. I think I like it. Let's see what you all were saying. Hey Leandro, do you like Radiohead? Yes, it's one of my favorite bands. A dude on Discord helped me create a playable patch that imitates the drums and synth pads of their song. It's one of my favorite songs. Really, it is. I freaking love that song. Yeah, and using pure data can be fun. I haven't really tried it, so if you want to send that my way. Yeah, that's the song. I liked it. Yeah. That album, Kid A, let me tell you, one of my favorite albums of all time. Right, okay, so yeah, this is fine as long as we have the sample rate available in the library, which is something that we need to check. Let's check that. Again, it's real easy. All we gotta do is... I don't think I want to develop in this folder. I think I'm gonna move it down there. There. Because then Reaper is gonna load this for me. Oh, thanks for sending, Fatis. I'm not even sure what this is gonna be. I think it's gonna be liafac tests, because we will need unit tests for these kinds of functions. So and then over here, I'll have like 100 milliseconds and convert that to samples. Bam, just like that. And I'll call that A. Then in Reaper. Oh man. Then in Reaper. There you go. Then in Reaper. Can take this out. I don't want to produce any audio. Let's find that and check milliseconds to samples is set, and A seems about right. If we had this as 500 milliseconds, it should be 24,000, and it is. Great stuff. So yeah, we can just have a factor like this. Now this is gonna work for this, and it's gonna work for that, and it's not gonna work for this. So I think I'd rather have a uniform interface for this. So it's a cute idea, but I'm not gonna use it. Okay, I don't think it gets better than this. Then this amplitude to the B The amplitude is a correct term to use here, but I think I would rather have linear to dB. And if the linear is 0, then the minimum, otherwise the formula to convert. And then dB to linear. I say that because I think we should also have a power version where we, instead of 20, we use 10. I guess it's just mostly for completeness kind of thing that I want to have the linear version and the power version. Right, and then radians to degrees and degrees to radians. There is a lot to see here. Why did I invert these two? Oh, kind of cute symmetry here. So with that, we can check the tests, and there's this new REAPER feature that I want to try. I wonder if it's documented or if it's only in the changelog, because I think that this feature will be relevant to the way that we see the results of the tests. So let's see. There's special variables. Let's try to find the changelog. This can write debug messages visible on the main plugin UI. So I want to play around with this. Dale talked about it last week, but I haven't really tried it myself. Can't find file liafac. What? Why would that be? Huh? It says hello now. Isn't that weird? Something weird just happened. Import, can't find file, blah, blah, blah. And then I close and reopen the window. I go to another app and come back, and then it does find the file. Does it have to do with this? I take it out. No, it doesn't have to do with that. It really cannot find the file. Oh, the file really is not there. So how is this working again? That's odd. It worked a minute ago. All right, the library is there. The file that is open is the right one. Okay, should be able to find the file now. Something weird is happening with my computer. Ooh. And it gets worse. Now I can no longer move my mouse. Spooky. I wonder if it's just Bluetooth. Let's try putting a cable in here. Ugh. Okay, guess it was just Bluetooth. But now the stream is all weird. Let's do that. And then I want to scale this to that. No, to this. And I'm not going to be able to see myself anymore. And I will have to check the chat from time to time, but I won't be able to read the chat in real time because Bluetooth went weird with me. Right. But now it's able to find the file. Great. And I suppose I can minimize this, keep the chat around. Righty. I sent some Radiohead goodies in Discord. Thank you. I'll check that. Let's close this one, and these two files are in the effects folder. They are in the right location. Great. So let's play around with that new variable now. Okay, and how long can this variable be? Guys, I'm always stress testing stuff. I wonder if I can use this variable to show me the test results. No, doesn't like that. Does it not like long strings or new lines? I think it may not like new lines. Yeah, but that makes sense. The variable is not really meant to be used this way. Now let's bring over some of the tests for this. It used to live in the demonstration effect. And we went up to here. Now this is something that I want to change about our naming convention. I used to namespace all the variables with where they are located. So instance variables belong to all different blocks and that kind of thing. And that was because the effect runs some parts of the code in parallel. And if you use the same variable name, they end up overriding one another. But that's only true, as far as I understand, the only two blocks that may run at the same time is the sample block and the GFX block. So having to namespace everything doesn't really make sense. I'm just going to namespace the stuff in the GFX block, which is also the convention used in JSFX. If you look at the variables that just come with, or the functions that just come with REAPER, only the GFX functions are prefixed. So I'll have something like that. And we did change this. So now it's no longer amplitude. It is linear. And we now also have another one for power. And these numbers are all going to be wrong. So the tests for these are not going to pass. But everything else should be passing. And now what we have to do is display this. So I'll have a GFX block and I'll do GFX str draw. Is that how you do it? I forget. Is there a tooltip for this? No. Oh no. Struct also has str in the name, so I'll be here a while trying to look for this. But if instead I go to the library, I think there is something in there that prints. Come on, print. GFX draw string. I almost got it. don't think I need any flags. How did that work? Oh, because these variables were just zeros. But that was not aligning as it should. And I do want to set some color so we can see. Otherwise it will be black on black. And let's see if the tests are passing. Some of them should be passing. I don't see much. I don't think that the effects even loaded. Spooky, isn't it? Now it loads. And now it does not. Let's try something simpler, like drawing a rectangle. Drawing a rectangle works. Am I missing something in the tests? Yes, I am. I think I'm missing this. Nope, still not quite there. Let's try to just write any string. Nothing. Is it because I enabled dark mode? Could it be that? No. It's all black. That is super spooky because it's not even giving me the usual interface that I get when I run JSFX. The edit button, oh, the edit button is here. Okay. Something is on the screen. I still don't see that. Okay. So it was one of the flags or something. Oh, maybe the right and bottom that I was passing, and I shouldn't have been. Great. Not great. It's flashing by. Oh, I need to set the X and Y positions. and now it stays there. Let's give us some space. And there you go. So these tests are passing and these tests are failing. The power2db stuff is failing, as expected. Great. I liked your track. Great. I also just visited your website. You have some interesting plugins there. Cool. Decided to upload prototypes as well, so there's going to be more plugins in a bit. Awesome. Haunted JSJSFX. Yeah, I am cursed today on the thing that I was working before the stream. It's like, oh yeah, this is easy. It's going to take me 10 minutes. It took me 4 hours. And I still haven't fixed it. So, yikes. Now, is this great? No, it's not, because it's not using the design system, but it's good enough. So let's fix the tests for power2db. That test should be passing, in fact. It is passing. Now this one is not going to be passing. Yeah, that sounds about right. So how do I get a hold of this number? Do I have to type it down? How did I do this before? I forget. I guess I probably used a calculator. Yeah, let's use a calculator. Because it's an opportunity for me to talk about a cool little feature of JSFX that not many people know. When you're doing a comparison with two double equals, it is using a kind of comparison that is kind of interesting. See, it's saying that the two numbers are the same. One means true, so it's saying that these two numbers are the same. And they are not. What this is doing is it's comparing if the numbers are close enough. So I guess it's taking the absolute value of the difference and comparing against a threshold. So it's something like this. A very small number like that, right? This is going to be 1 as well. So when you say something like this with 2 equal signs, it means that. But if you have 3 equal signs, then it means really, are these two numbers the same? Tell me. And then it tells you no. So there is the 3 equal signs sort of trick. The same way that there is a 3 equal signs in JavaScript, there is also this in JSFX. And I'm saying all this because I don't have to necessarily get the number right down to as many decimal places as this is giving me. Just have to get it right in the ballpark. And the implementation of this, let's find power2db. So the formula is 10 times math log 10 of that. I probably used a different calculator for the other test because there are fewer decimal places in the other test. This should be the same as that. This should be passing and -1. -1 is not a number. Oh yeah, okay. I'm checking. If my number is negative, I'm taking the absolute value. So yeah, that's symmetric. And then 2. Wait a second. Does that make sense? Yes. That does make sense. And And then, just like that, I think that tests will be passing. Let's see some passing tests. And we have some passing tests. And that's kind of weird. I was expecting that a full compile reset was not going to reset the variable, but it did. So I ran into issues before where the full compile reset was not resetting the strings. It seems to be now, so good. We can make a test fail, and then we can do a full compile reset, and nope, we don't see that. Oh, we see. Yeah, I can just save it, and it's gonna reload there. Awesome, quick feedback, lovely. Just making sure that I didn't leave everything in a bad state. Okay, auxiliary functions for unit conversions are in the bag. Then the imaginary numbers are kind of weird. I think I may need to have some sort of data structure because it needs to return two values. It's kind of weird when you get into imaginary numbers. And hyperbolic functions, that's pretty straightforward. Let's do the hyperbolic functions. Yeah, most of these, yeah, let's leave the data structures for next time and just focus on these ones. Quick wins to get us off the ground. Thanks, that's very nice of you, but it's in the documentation. That behavior of the equal sign is actually in the documentation. If you watch carefully a stream a couple of months ago, we talked about denormalization, and they explained what it was, how it worked, and then I wrote a little loop to test and increment the small amount of noise that JSFX adds to the signal to prevent denormalization from happening. And in the test, it actually didn't work all that well, and that was because I was using 2 equal signs instead of 3, so I made a fool of myself. Right, is there anything that I want to change about these functions? I think that they are good. Maybe this follower situation I want to change. Maybe have reasons for that, because this follower is implementing one strategy for followers and there are many. So I think I should be more specific here. But I'm not going to worry about this right now. Let's go to the demonstration effect and find stuff from hyperbolic down to distance, Euclidean distance. Move that to the tests, paste that there, and then we need to do that same renaming that we did before, where we remove all the instance dots. And that's pretty much it. Let's give this test a bit more space to breathe, so maybe 600 by 800, something like that. Loading this in REAPER. And they're all passing. I think that I will need a Git repository here to keep track of development in my Reaper configuration folder directly. So all of that looks good. All of this looks good. Then all of that is gone. So, oops, I didn't save something. Okay. How about that? Okay, so the schedule is tomorrow I'll be back here and we will have Aria over and we'll continue our conversation about composition for orchestra. I'm going to show my homework. I'm developing this, I'm composing this duet for cello and flute, and we're going to talk about that. And then on Thursday, I'll be back here for more of this, and we will talk about the data structures. So we're going to implement the thing that I talked about, where we take care of memory and we let the data structures not be values. Try to simplify this code, implement that trick of using negative indices to push some extra data for the array, like the size to the left, so we can use arrays more naturally and that sort of stuff. So that's on Thursday. Yeah, remember the denormalizations, good memory. And oh yeah, so I suppose that you are talking about this study group that we are gonna get off the ground, and yeah, where can you find that Discord stream? I'm not really sure. What you can do is get an invitation from here to this group, and then that, and then create invite, copy, close. Should I be doing that on the stream? Are there like secret tokens on the screen? Or yeah, I don't know. But all right, you can go there and you can join us in the little Discord room that we have to. Oh, I can accept an invite and then it doesn't work. Great. So in that channel, we will be talking about what we do on the stream, or what we will be doing on the stream, or what we have done on the stream. And one of the things is this study group. We'll talk about C++ and digital signal processing in C++, and we'll be reading a book together. It will be great. So I think that's what you are talking about. And I invite you all to join us in this study group. I think it will be great. I'll sign off now. I see you tomorrow for some orchestration, and I will have to change screens the good old-fashioned way, like the non-pros do it. See you tomorrow. Bye.